Okay, this is part 5 for chapter 2. This is the last part. So there's 5 videos for this chapter. All right, let's move to the PowerPoint. So the last part of this is scientific notation, and that is numbers that are written in the form of m, which is whatever your measurement is, times 10 to the n. So that's your exponent. So m is a number greater than or equal to 1. So you're not going to have 0 times 10 to the something. And you're not going to have 0 in front of non-zero numbers for scientific notation. You're always going to have a non-zero number first, and then a decimal point, or no decimal point, and then you can have zeros after the decimal point. But less than 10, and n is a whole number. So you can have 10 to the whatever power, but it has to be a whole number. It can't be 10 to the 10 to the 0.052. It can be negative, it can be positive, but it has to be a whole number. Okay, so remember no commas, there's just a space. So this is 65,000. It's not 65 and then random zeros after it. 65,000, and we need to put it in scientific notation. So this first number has to be greater or equal to 1, but less than 10. Because we only want to have one digit here before the decimal point. We can't have 10, or you'd have the decimal point after the 1. So we put the decimal point after the first number here, which is 6. 6.5. We don't need these trailing zeros because that's the whole purpose of writing scientific notation. So you don't have these really large numbers. So 6.5 times 10 to the 4th. That 4 indicates how many spots you move that decimal point to get right behind 6. So we moved it 1, 2, 3, 4. So it's 6.5 times 10 to the 4. And that really means that you multiply 6.5 times 10 4 times. Or it can mean that you multiply 6.5 times 2, 3, 4. So that 4 indicates how many zeros there are that you multiplied 6.5. So if you multiply 6.5 by, looks like 10,000, I'll put that space to be consistent, then you'd move the decimal point to the right 4 times, and that will give you our original number, which is 65,000. So that's what this 4 means. It indicates that you multiply 6.5 by 10 4 times, or by 10,000. That indicates how many zeros after the 1. When you write a number inside scientific notation, you only see the number of sig figs. So you see this number right here. How many sig figs are there? There's 2. When you write it in scientific notation, we only are going to include 2 sig figs. We're not going to put 6.50. If we did do 6.50, then that means that there'd be 3 sig figs. So we only want 2. If you ever have to figure out the number of sig figs of a measurement that's in scientific notation, it's really easy because you just count how many numbers there are here, because you only write a measurement scientific notation including the number of sig figs. So it's really simple there. Okay, so doing these examples, I'll do them with you. 0.00012. We want the decimal point after this digit right here, not after the 2 because it has to be less than 10. So we want it to be 1.2. Okay, we want the decimal point after the first non-zero number. So how many spaces did we move it? We moved it 1, 2, 3, 4. We moved it 4 spaces to get over there. So we have 10 to the 4. Is that true? If we take 1.2 times 10 to the 4, we multiply it by 10 4 times, we'll have this number, 1, 2, 3, 4. And that's not this number. So we didn't multiply it by 10 4 times, we divided it by 10 4 times. And when we do that, we put a negative exponent. So negative exponent indicates that you divide it by 10 4 times. So that would be 0.00012. And I'll use this fraction for the dividing symbol. Divide by 10, divide by 10, divide by 10, divide by 10. And that's really moving the decimal point to the left 4 spots. So if we move this decimal point to the left 4 spots, 1, 2, 3, 4, we get this original number. So negative exponent means that you divide it by 10, even though there's still a multiplication sign here. That's how scientific notation is set up. But the negative indicates that you divide it by 10, however many times that exponent is. So that is what you use for negative exponents. Okay, the next one, you might have it in scientific notation, have to take it out of scientific notation. So you can see that that's the same number. So you take it out of scientific notation and you'll get the original number of 0.00012. And you really don't have to have that space there. Okay, on your calculator, because you have to have a calculator for this class, to put exponents in, and when you multiply and divide, you don't have to worry about parentheses if you use this simple tool. Let me try and make it bigger so you can see that EE. All right, on your calculator, you will have a symbol that looks like this, EE. And it may be like you might have to do second and then EE for some of them. So find that EE button, and that EE means times 10 to the. So when you hit that button, you're really hitting times 10 to the. And you don't need to put parentheses around the whole measurement if you're like dividing or something. You just have to click that EE button. So it's a lot simpler. So if you want 5.44 times 10 to the 7th, you put 5.44 EE 7. And that's what it'll look like right there. So you don't have to put 7 zeros, and you don't have to put parentheses. And maybe your calculation, you have to divide it by like 8.1 times 10 to the 4th. So you put 8.1 EE 4. And this might have to be a negative exponent. So all you do, usually the negative sign is down here. You just click negative and then 4. So that's 8.1 times 10 to the negative 4th. So then that's all you do for your calculator, and it's really simple. Because you don't have to deal with parentheses and you don't have to put like times 10, the caret for the exponent. All you have to do is click EE. So remember that. Come back to this or look at your PowerPoint or ask me. All right, so when multiplying or dividing scientific notation, you just put the EE in the calculator, and it's really simple. And this means micro, remember. And then it'll spit out the number, and you will get 37.133 times 10 to the 4th. So you can see that these exponents are subtracted from each other, and you'll get 4. And then if your calculator gives you that, which I think it should give you that, make sure you have the right sig figs. Since you're multiplying, you want the least number of sig figs in your measurements. There's 3 here, 2 here. So here shows you 5. You only want to have 2. So move that over 1 and drop all these numbers, and you get 3.7 times 10 to the 5th. So you can change your answer to make sure you have the correct number of sig figs. Same with here. There's 3, there's 2. Your answer should have 2. Calculator might give you this huge number, but just move the decimal point. So it's after the first non-zero number, because this is a 0. So that's not a correct scientific notation. So put 6.7 times 10 to the 2. So you're smarter than your calculator. So whatever the calculator gives you, it may not be the correct answer. It's the correct answer, but you might have to change it a little bit. Okay, the last part of this chapter, looking at direct proportions. So 2 variables might not be, it helps you to know how they're related. When things are directly proportional, it means that when one unit goes up, the other one will go up as well. So an example is if the temperature goes up in a gas, so does the volume, because the gas will expand. So the volume and temperature are directly related. So they are indicated as they're multiplying each other. They divide each other right here, y over x, and maybe this is the volume, this is temperature, equals a constant. Last part, inversely related. When one goes up, the other one goes down, and they will be indicated as multiplying each other in some equations that you'll see. Okay, that's it.